Hello students, today we are going to see about the case study of fuel control. So this course intelligent vehicle technology in the unit engine control system. So let us move on to the case study. Before going into the case study, everyone should be aware of the fuel control. So what is by fuel control? So fuel control is the strategy followed in the modern vehicle that the existing system, the carburetor system is replaced with the fuel injector system. Later on, it is nowadays we use it as a MPFI or a CRD system. So we should know the basic difference between the existing system and the modern system. So you can see the existing system here as the carburetor fuel injection system, carburetor fuel system, and the electronic fuel injection system. So in this system, the first is the distribution. So here is the in electronic fuel injection, it is a uniformly distributed, whereas in the carbureted, it is a what we can say is a naturally aspirated system. And the volumetric efficiency is more rich in electronic fuel injection because the fuel is sprayed in the atomized form, whereas the carbureted fuel system, the according to the resistance in the intake manifold, the efficiency is lower. And accuracy, the accuracy is about the charge that is controlled by the ECU in terms of electronic fuel injection, whereas here in the carbureted fuel injection it is the inaccurate metering of charges entered inside the engine. The formation of ice on the throttle plate is eliminated, whereas in carbureted system, according to the atmosphere temperature, the air is naturally aspirated, so there may be a chance of the water particles drawn into the carburetor. So there is a change in the combustion and the fuel is not efficiently burnt. The atomization of fuel is independent of cranking speed, therefore cranking is easier, yes. Whereas here the atomization depends upon the velocity of air in the venturi. Better atomization and vaporization will make the engine less knock prone. Whereas here the engine is more knocking. Knocking in the sense the unburned fuel burns after the combustion chamber. That is, the term is called knocking. So it has a hammer effect inside the engine which creates vibration and noise. So that is nothing but knocking in simple term. Here a less volatile fuel can be used, whereas here the fuel volatility of the fuel should be more. The fuel injected into the cylinder is very closer or into the cylinder, whereas fuel injection takes place inside the manifold only. So this is the basic difference between the fuel electronic fuel injection and the carburetor fuel injection. So if you can see the electronic fuel injector, so the injector basically works with the solenoid winding. The solenoid winding is energized by means of the ECU, the power supply, so that the forward and return stroke happens. So suction and compression happens. The fuel is sprayed atomized form. So the basic system is divided into three types. That is electronic fuel injection, fuel delivery system, air induction system, the electronic control system. These are the three modules of the electronic fuel injection. First is the fuel delivery system. The fuel delivery system is, you can see in the slide, it is shaded in the gray color, which has a major components such as fuel pressure regulator, fuel return pipe, fuel delivery pipe, fuel regulator, fuel filter, fuel tank, and fuel pump. Fuel delivery system, you can see, as I told, the major components. The fuel is delivered from the fuel tank to the injector by means of a fuel pump. The pump is typically located in or nearer to the fuel tank. The contaminants in the fuel are filtered by means of a high capacity inline fuel filter. Fuel is maintained at a constant pressure by means of a fuel pressure regulator. Any fuel which is not delivered to the intake manifold by the injector is returned to the tank through the return pipe. So the next module is the air induction system. In air induction system, you can see the shaded region, air cleaner, air flow meter, throttle valve, air intake chamber, intake runner, intake return valve are the major components. So you can see the major components as listed. The throttle valve is opened, air flows through the cleaner through the airflow meter. It is basically an L-type system. Past the throttle valve and through a well-tuned intake manifold runner to the intake valve. Air delivered to the engine is a function of the driver demand. As we all know, how much throttle is applied. In such case, it is directly proportional to the air delivered. Yes. As the throttle valve is open further, more air is allowed to enter into the engine cylinders. Toyota engines uses two different methods to measure intake air volume. One is a L-type EFI system measures the airflow directly by using airflow meter, and another one is the D-type EFI system. EFI is short form of electronic fuel injector, measures airflow directly by monitoring the air pressure in the intake manifold. The last system is the engine control system. You can see here ECU, which has the input from the various sensors such as throttle angle, throttle position sensor, coolant temperature, airflow, exhaust oxygen, and engine RPM. So the electronic control unit consists of these sensors, input from these sensors. It determines precisely how much fuel needs to be delivered by the injector by monitoring the engine sensor. ECU turns the injector on a precise amount of time, referred as an injection pulse with our injection duration, to deliver a fuel so that proper air fuel ratio is delivered to the engine. Basically, the system is operated as air enters the engine through air induction system where it measures the airflow meter. As the air flow into the cylinder, fuel is mixed into the air by the fuel injector. Fuel injectors are arranged in intake manifold behind each intake valve. The injectors are electrical solenoids which are operated by the ECU. ECU pulses the injector by switching the injector ground circuit on or off. So going back to the case study, before going to the case study, the advantages: uniform distribution, high accurate, superior throttle response and power, excellent fuel economy, improved cold engine start ability, simpler mechanism, reduced adjustment sensitivity, and most of the thing here is the mechanical parts are eliminated. That is a major advantage of EFI. So here is the case study about the Toyota computer control system. So with the introduction of Toyota computer control system, the EFI system went from a simple fuel control system to a fully integrated engine and emission management system. So here in this case study, the Toyota control system, the electronic fuel injection system works based on the inputs of the emission management system. That is a major advantage of the system. So it gets input from the emission management system such as the unburned fuel, the amount of unburned fuel present in the exhaust, the amount of hydrocarbons, the amount of nitrogen oxide, or the contaminants or the gases that are present in the emission. According to the emission gases, the oxygen sensor fed input to the EFI, that is electronic fuel injection, which adjusts the fuel mixture ratio so as the fuel system is very much efficient compared to the traditional way. Although the fuel system operates the same as conventional EFI system, the modern TCC, that is Toyota Computer Control System, also controls ignition spark angle. Additionally, it regulates an idle speed control device, an exhaust gas regulation, vacuum switching valve, and depending on the application on the other engine related systems. Electronic spark advance is the advanced mechanism where it regulates the spark advance angle by monitoring engine operating condition, calculating the optimum spark timing, and firing the spark plug at the appropriate time. Idle speed control is one of the another module in this case study. Here it regulates the engine idle speed by means of several different types of ECU control devices. The ECU monitors the engine operating condition to determine which idle speed strategy to use. Exhaust gas recirculation. The system regulates period under which exhaust gas can be introduced into the engine. This control accomplished by through the use of EGR vacuum switching valve. TCCS also controls ignition spark angle additionally and regulates idle speed control device and exhaust gas regulation vacuum valve and depending on the application of other engine related systems. Other engine related system in addition to the major just described in the previous slides, it often operates electronically controlled transmission, the variable induction transmission, that is simply called as VIS, the air conditioner, compressor, clutch, and the turbocharger or supercharger unit. It also has a self-diagnosis system is used to control units and into some conventional EFI systems. A conventional EFI engine equipped with self-diagnostic is a P7 or EFI system. This diagnosis system uses engine warning lamp in combination meter which capable of warning the driver when specific faults are detected in the engine control system. The engine light is also capable of flashing the series of dynamic codes to assist the technician in troubleshooting these faults. So overall, this Toyota computer control system is one of the modern system, and through this case study, we came to know about the various modules that uses this system as a powerful tool in tuning the engine according to the performance. So let us see another case study in the upcoming classes. Thank you.